All right, so let's look at the rest of this 2.3 section. And there was one more equation on here. It was kind of all the kitchen sink in it. All right, so what we got is we got an 8 to distribute times x minus 3. We got a negative to distribute to a 6 and a negative 2. We got a 2 to distribute on the other side of the equals sign times an x plus 2, and then a negative 5 times the 5 minus x, okay? So this has got 4 distributions in there that's got to be done. So 8 times x minus 3, no double negatives, so it's 8x, and then 8 times negative 3 is negative 24. All right, as I'd mentioned before in a similar example, this negative right there, it's just going to change the sign of these two. So it's going to be negative 6 and negative of a negative 2, which is a positive 2x. All right, 2 times x plus 2 is 2x plus 4, and then negative 5 times 5 is negative 25. Negative 5 times negative x is plus 5x. So there we've got everything out in the open, and the first step would be to combine the like terms on either side. In other words, if there's some things that go together without, let's put those together over here. And look at that, we do have some. Let's see. We got an 8x and a 2x, which is a 10x. Negative 24 and negative 6 is negative 30. Then over here, we got a 2x and a 5x, that's 7x. 4 take away 25 is negative 21. And there we are before we get ready to do our algebraic properties. All right, so subtract the 7x. So now we're going to combine on the other side of the equation. So that's where we have to use the addition property. So subtract the opposite. So 7x, take away 7x is going to be 0x. But what we do on the left-hand side is also subtract 7x from 10x. So we got 3x minus 30 is equal to negative 21. Now add the opposite of this one so we can combine our numbers there. So negative 30 plus 30, this has gone away. Negative 21 plus 30 is 9 positive. So 3x is equal to 9. Divide both sides by 3. Same thing as multiplying by 1/3. So x is equal to 3. And then you can put it back into the equation to see that it gives you a true statement. All right. So why don't you folks work on the, let's see, it was these over here. These were the ones. Do 12 through 14, and when I start hearing a couple of answers out there, we'll move over to the board. Let me know when you got something. All right, anything on that first one?
I got negative 27y equals 4y. Oh, I'm sorry. I didn't see the 3. I wrote a 2 down on my paper. 5y?
Yeah. Well, you got a sign change, but 5y is equal to what?
Negative 27y?
Well, I don't see where you're getting a 27 at, but look at it again and then go on to the next one.
Oh, anyway.
I'll go over all 3 of those in a second.
Me neither.
So you have to always be on FaceTime with him?
Mm-hmm.
Wait, why are you asking? Why are you waiting to tell?
For number 12,
Mm-hmm.
I got y equals negative 12 over 5.
Okay. I think you're right on that. I'll work it out and let's see. What about that second 13? I think that's a pretty straightforward one. This one's got fraction in it. That 12 has got a fraction. I think this is pretty straightforward number. This one's going to be rather bizarre, but we do know what the solutions are to that. We just kind of got to.
Okay, for number 13, I got A equal 13, but I don't know if it's right.
That sounds pretty good. Well, like I said, that's what you can always do is just check it back in there. Put your 13 back in place of A, see if you come out with a true statement.
Okay.
And what about that last one there? Okay, I'm going to write number 12 here. All right, so over here on this one, it's distribution -3y. And then it's -3y times +3, -9, right? So then over here, it's going to be 2y plus 3. Those don't need anything done to them. All right. We can subtract either side that we want to put the y's on. I'm going to put them over here because we're going to have a negative anyway, no matter what we do. So those are gone. So that's -5y minus 9 is equal to 3. And then plus 3. Oops, I'm sorry, plus 9. So -5y is equal to 12. And that's one of the things I heard out there was when we divide both sides by 5, negative. Okay, so there we go. All right, any questions about that one? Okay, let's go on to this next one. So it's 2 times the -3a and the 5. So -6a, +10. And then -4 times a, -4a. And -4 times +4 is -16. Everything look okay? All right, so again, we can add 6a or we can add 4a. It'll just be a matter of what side it goes on. Let's go ahead and put 4a, generally speaking. I like to put my variables on the left-hand side. Doesn't have to be. And then -10. And if we had done them just the opposite, in other words, put the a's on the right and the numbers on the left, they would have both been positive because look at this. 2a is equal to -26. A is equal to 13, and I heard 13 out there earlier. And you can check it back in there and see that it works. All right, now what happens on number 14? As I said, there's something strange going to happen.
Okay. I got x equals 0.
All right, let's see. How are you getting x equal to 0? Something doesn't seem quite right.
It's a true statement. It's
All right, good. Yeah. You can tell it right after you do this initial distribution right there that they're both the same. If you try to collect the x's on one side, what happens? -4 is equal to -4. Oops, no more x. So this is the problem now. There's no x. All the x is gone. If you try to just do one more time by putting +4, you get 0 is equal to 0. All right, so the way this works is so the solution is all real numbers, and you could kind of test this if you wanted to. Put a 1 in here. See what happens. That would be 6 minus 4, so that would be 2, and then you put the same thing over here. 3 minus 2 is 1. 2 times 1 is 2. So that would give you a solution. But the thing is, you put 0 in here, it will also work. You can put 2 in there. You can put -1. You can put a host of numbers in there, because any real number will act as a solution because you came up with a true statement. Now, there's a counterpart to that, but it's not on here, but I'm just going to give you this. And I'll just write it down here on the bottom. Let's say we got -16 is equal to 5. So that's obviously not true. No solution. So if you come up with, instead of coming out with a true statement, you come out with a false statement. The false statement just tells us that there's no solution. And if you got a true statement, it means all real number solution. Okay, questions about that?
For 12, how did we get a fraction?
Well, is that 12 right? 3 plus 9 is 12. And what happens when you divide 12 by 5 negative? You can't simplify it down. Doesn't simplify down to a whole number.
Okay. Okay, I got it.
It doesn't simplify down to a whole number. You leave it as a simplified fraction. -2 2/5 is, I guess, what you get another way of putting it. But generally speaking, in algebra, you're always better at just leaving things as improper fractions, assuming that they're simplified. All right, let's go back over to the board over there. Oops. Not to the board, but to the worksheet. All right, now 15 and 16 should be pretty straightforward. And then when you get to this one, I'll just kind of give you a hint right here. If you don't like working with those fractions, what you can do is, if you multiply by the least common denominator of those three things, you will lose all your fractions. And then you'll have an equation that's equivalent without any fractions in it. Because look at that. If you got to combine 4/5 x and -9/10 x, so you still got to deal with LCDs, but you're better off just finding the 1 LCD for all of the denominators multiplying by it. So give it a try if you can, and then I'll get to that one in a bit. Tell me when you get a solution on that first one.
I've got x equals 11 over 10.
Over 10?
Yeah.
That seems close, but I'm a little bit concerned about that 10.
Okay.
It's just 11.
11 seems right, but I don't know how you would be getting that. 10x.
I messed up. I changed the sign.
Yeah, well, that's really easy to do. So I figured that's probably what it was.
Okay, I got x equals 11 over 2 negative.
All right, that sounds good. Anybody else got one? Sounds similar? Let's go on to 16. Let me know. Okay, thanks, Makita.
Oh,
All right, anybody come up with a second one?
okay.
-1.
-1.
-1.
Okay. All right, let's look at these and then I'll come back to that fraction one. Okay, so this one's got distribution on the right. 4 times 5 is 20. 4 times negative x is negative 4x. Okay, so now add the 4x. Add the 4x. So here they're all gone, and then this is negative 2x plus 9 is equal to 20. And then we're going to subtract the 9, opposite, to get rid of it from over there. And we got negative 2x is equal to 11 positive, because it's 20 negative 9. All right, questions about that one?
Yes, I just got 11. I don't know. Wait, hold on.
What's the matter? All right, so let's do this one. So I assume that y'all got no problem with that one. If you got any question about it, let me know, because all right, so negative 5 just comes down, and it's negative 2 times x, which is negative 2x. Negative 2 times negative 3 is positive 6. Now we can put these two together on that side. So negative 5 and positive 6 is positive 1. All right. So I'm just going to do traditional, get the x's from the right, collect them on the left. So 5x plus 6 is equal to 1. That's a 6, a terrible looking 6. Let me see if I can fix that 6. All right, so now when we try to collect the numbers on the right-hand side, we're adding the opposite, the negative 6. And then divide by 5. Remember, we won't dividing here by 5 or multiplying by 1/5 to get that into just a plain old x. And anything over itself is 1. And there's one negative sign, so it's negative 1. And you can kind of easily check that. So that would be 1 times, because negative 1 is in there, plus 2, that would be just a 1. So that's 3. Negative 4 would be here, because negative 1 is 3, so negative 4. So that's 8. And negative 5. So that's 3 as well. So, all right. Good. All right. So, if you like working with fractions, like finding this common denominators and then adding and subtracting it. You'll have to do it a couple of times. That's fine, but I'm going to show you how to eliminate any fractions. All right. All right, so the LCD for those is just 2 and 5. Two times 5 or 10. All right, so I'm just going to try to now, remember, since we're multiplying fractions, we got to make sure we get these things lined up right. So 10 is 10 over 1. So I'm just going to put it laid in here first. This is just 10 over 1, and that's just 1 over 1. So that's not going to have to worry about lining anything up there. So this is has the effect of multiplying by 10. All right. So let's start over here on the left. 5 goes into 10 twice and into itself once. So when we multiply through with that LCD, we lose the denominator and we've just got a plain old 8x. 2 times 4. X. Here it's just negative 10. We essentially multiplied everything by a factor of 10. And then here, that's just going to be 9x. And this is 2 goes into 10 5 times and into itself once. So that's just a 5. Now, this equation is a lot easier to deal with than dealing with a bunch of fractions. So it's all whole numbers. So now let's just proceed normally. Does anybody get an answer on this yet?
I got negative 15.
Sounds about right. All right, so this is going to be 8x, take away 9x, so that's negative x is equal to 15. Now, whenever you've got a negative x equal to something, you're not finished because we need to know what x is equal to. So what we got to do is multiply both sides by negative because we need to have this as a positive 1x. So we're going to just change the sign, but we got to do it to both of them. And put a 1 in there if that makes us feel better. But it just changes the sign. It doesn't change any numbers. All right, good.
Professor Cruz.
So did you do it the way I was showing you, or did you just try to do it with the fractions?
Professor Cruz,
Mm-hmm.
why did you add the 10?
I didn't add any 10. Where did I add a 10 at?
Why you have plus 10, you have 8x minus 10 equals 9x plus 5, which I have 8x minus 10.
Oh, well, because there's a 10 here, a negative 10 here.
Okay.
So I'm
then
getting rid of it over here, so I don't want it here. So I add the opposite of it. So these are gone now. That's what happens
right,
when I put that line through it. That means they're gone.
Right, so I set it up as 8x minus 10. Maybe I'm skipping a step, but I put 8x minus 10
Mm-hmm.
minus 9x. I'm sorry, I was supposed to bring the 9x over on one side. Yeah, I
Right.
am.
That's what I did here. That's what that is.
8x minus 10 minus 9x equals 9x plus 5 minus 9x, right?
Mm-hmm. The tens are gone here. The nines are going here. The only thing left on the right is 5 and 10, which is 15. And then
Okay.
x, take away 9x is negative x.
What section are we on? Like chapter
2.4. I think it's
2.4?
2.3 or 2.4.
Okay.
All right, so try these last ones. There's nothing to these first two. They're pretty much just the same line. This one, I'll just kind of tell you, you can handle it very similar to 17. But notice what this is when you've got two hops there to get to a whole number. You go 1, 2. That's essentially multiply. We need to multiply every one of these terms by 100. And if we do that, we'll no longer have those decimals. So keep that in mind. But if you want to work with it with the decimals, you can. I remember I had a student recently that, they didn't mind working with the decimals and they got it right. So that's fine. It's just that I'm just kind of trying to show you some things to be helpful.
You haven't switched over to the worksheet.
Okay. Okay, how's that? Two times x minus 3 is equal to x minus 1 plus 7. I'm not sure why they got the x minus 1 in parentheses. It doesn't really do anything. 19 makes sense because there's a negative in front of both of those terms. Hold on a second, I'll be right back. Okay, I just want to make sure I had them up there. All right. Just yelp when you get an answer.
I got 14 for 18.
Okay. What about 19?
Three.
And what did somebody just say about 18?
18, I got 14.
I got 6.
Yeah, I check both of those actually. No, wait a second. I'm sorry. It's x minus 6. No, that's right. X minus 6. X plus 6. Okay. All right, what about 19? Did somebody say X is equal to, 3 or something like that?
Yeah.
All right, and then 20, and like I said, take a poke at it if you can. Like I said, is what I'm gonna show you is just moving each one of, there's 3 terms there. And we're just gonna move the decimal part because each one of them has 2 decimal places. So we're gonna move over to the right and make it a whole number. And that's a effect, the same effect you would have by multiplying by that LCD on that number 17 thing.
I did 18 over. I got x equals 12.
All right, well, let's see.
Mr. Cruz,
Mm-hmm.
you could explain number 18.
That's what I'm gonna do.
All right, thanks.
All right, so 2 times X is 2X. 2 times -3 is -6. Now over here, you got just 1X and you got a -1 and a +7. So that it means X plus 6. So 2X minus 6 is equal to X plus 6. You got that? Because these things right here, I'm not even sure why they put those parentheses in there, just to give you something extra to do. But there's nothing multiplying them, so nothing changes. They just pop out as X minus 1, and then the -1 and the +7 give you the +6. So now getting rid of the -6 over here, we add 6. So that's going to give us a 12, gives us a 2X on the left, another X. So we subtract X. X is equal to 12. And I think that's what I heard, isn't it? Okay.
I don't get it.
What did you get?
Let's see. Okay.
You got 2X minus 6 is equal to X plus 6.
Let me see. Yeah. That's what I was doing wrong. Okay. Why don't you have to do anything with the 2? You don't have to subtract the 2. You just
What
subtract
2?
the X. The one all the way at the bottom, like by the problem, right here. Yeah, that one.
Well, I did. I subtracted X here.
Wouldn't we still have a 2?
2X minus 1X is
Oh.
1X. These are the same terms. So you had 2 of them. You're taking one of them away. You only got 1 left. So X is equal to 12.
Mr. Cruz.
Mm-hmm.
Okay, so you got, and why you got rid of that -1 at the beginning?
I didn't get rid of it. Look. -1 and 7. These are both like terms. So what's -1
gotcha.
plus 7?
Gotcha.
Those are like terms.
Gotcha.
So it's 2X minus 6 is equal to X plus 6. And then, like I said, then I get rid of the -6 by adding 6. So I add 6 over here. So that's where I get the 12. Then I got 2X is equal to X plus 12. I got this X to take care of. So I undo it. X is equal to 12. So let's see, 12 minus 3, so that's 9. 2 times 9 is 18. And then the same thing here, 12 minus 1 is 11. 11 plus 7 is 18. So that's a good answer. All right, let's look at this one. All right, now, as I said, like this x minus 1, it had parentheses around it. I wasn't really doing anything, so I just dropped them because there's nothing to multiply. But over here, I got a negative sign in front of x plus 7. So that's changing the sign of both of them. It's subtracting x and it's subtracting the 7. So it's negative x, negative 7 now. On the right-hand side, it's negative 6x plus 8. I'm going to, so it's a negative 6x here, plus 6x, so those are gone. See, those are gone. And so negative x plus 6x is 5x, minus 7 is equal to 8. Now, to get rid of this cat, the negative 7, we add 7. So those are gone. And then what's left over here is 8 plus 7, which is 15. 5x is equal to 15. Multiply both sides by 1/5 or divide by 5 gives you x is equal to 3. And you can check it. 3 plus 7 is 10, negative 10. So this is 3 times 8, negative 18 plus 8 gives you negative 18 as well, negative 10 as well. So that's a good answer. All right, so what was I going to show you over here? Like I said, is if you like working with the decimals, you're free to do it. Like I said, is I just like to pass along these things that kind of make them a little bit easier, because working with whole numbers is, in my opinion, better than working with fractions or decimals. So notice what we got here. We got 1, 2 hops to get right to that spot right there, right behind the 3. That's 1, 2 decimal places. And as a matter of fact, it works for all of them. All right, so now when we do that, we've got a 3 times x plus 4. And we got a 2 times 5 minus x plus the 6. All right, now we're back to dealing with all these whole number things. It's going to be a little bit easier to do. 3 times x is 3x. 3 times 12 is, 3 times 4 is 12. 2 times 5 is 10. 2 times negative x is negative 2x. Bring down the 6. All right, now 10 and 6 is 16. And then also subtracting 2x, so these are going, means that I've got 5x. Now, to get rid of that number there, 12, I undo it. Negative 12 to both sides. Whoops. That's right. It was just that this is it's negative 12, so this is 4. There we go. 16, take away 12 is 4. All right, any questions?
So how do you know when it needs to be turned into a fraction or not?
You mean turned into a fraction?
Like for 20, we had a fraction as the answer.
Well, how else can you write that? If I've got 16, take away 12 is 4, and then I'm dividing both sides by 5, I don't have any choice but to write it as a fraction. 4 divided by 5 is 4/5. I'm not changing it to a fraction. I'm just solving for x. And that's what I get. And that's really the whole goal. You're doing the operations based on getting the X's by themselves. So that's why you have those two properties. First of all, you get rid of the numbers on one side. So the numbers are on this side, the left side, I'm sorry, the right side, and the variables are on the left side. And then once you got that, then you're multiplying by 1/5 or dividing by 5, same thing. So 4 divided by 5 is
okay.
4/5.
Okay.
Nothing shady about it. It's just, that's the way it whacks out. There's nothing else I can do. Let's see. All right, well, let's take a little break. I had to go in for my first face-to-face class a little while ago. I'm more wrapped out. So get a little bit of rest and we'll come back. I might let you go a little bit early today at night because we're doing all right on time. And okay, oops. All right, so what is it, 6x?
5/6 x minus
Mm-hmm.
1/2 equals 2.
2.
All right.
Okay, so
Yeah, my least common denominator.
what is it?
The fractions, I have 6.
And that looks good to me. So you multiply this one by 6?
Yes. And multiply the 1/2 by 6.
I'll try to squeeze it in here. Oops, what happened? Oh, wait a second. That's the other board. What? So 6/1 here.
Mm-hmm.
And then it's going to be times 6 here. You can put them both over 1 if you like, but
That's
the
the
reason
step that I didn't
that's what
multiply
it's,
2 times 6.
yeah, because the reason why you're putting over 1 is just so that the numerator and denominator lines up. So these gone, it's just 5x.
5x, yeah.
Here,
It's 3.
negative 3. Oops,
Mhm.
wasn't what, oh, was this an x over here on the right hand side?
No. You have that right. It's 2 times 6. Yeah.
Okay.
Equals 12. That was the step that I missed. I forgot to multiply the 2
Yeah,
times.
and because you got to multiply every term by that same number in order for this property to work. That's what they call the addition property. As long as you multiply everything in an equation by the same factor, then the equation is going to be the same. And see, you lost all your fractions here.
Gotcha.
And this is an equivalent equation.
Mm-hmm. Plus 3. Okay, that's where I went wrong.
So 5x is equal to 15.
Mm-hmm.
And then dividing both sides by 5, and we got x is equal to 3.
Got it. Thank you, Professor Peruz.
Mm-hmm.
I realized what I did wrong.
I have a question about
Mhm.
that one. So basically, in the first two before the equal sign, you cross multiplicate them. You made a cross
No,
multiplication.
I'm
with
multiplying everything by 6/1. Okay. And if I do that, then you'll see that these factors will cause it to drop out. See
Okay.
that? Because 6/6 That's 1.
Oh,
The only thing that's left is 5x. Did the same thing here. I'm multiplying by 6 over 1. So this ends up just being a -3 because it's 1/2 of 6. And then over here it's 12. Now, like I said, you don't have to eliminate the fractions. See, because you could just work, you know, with 5x and just manipulate, you don't have to do that. It's just, I like no fractions. So now you got to, whoops, what happened? Let me go back to the original and I don't know what I'm doing. It's 1/2 is equal to 2. That's it. So what you got to do is you got to add 1/2 to both sides. So what happens when you do that and you do into whole numbers? So you still got to work with fractions. So my contention is just multiply by the least common denominator. And this is 3/2. So see, you still got to work with fractions. But if you find the greatest common factor and multiply by that, you no longer have any denominator. So this is going to be x. Hold on. See, this is why. Did I write it down right? 5, 6x minus 1/2 is equal to 2. Oh, it's plus 1/2, so it's 5/2. It's plus 1/2. So x is equal to 3. That's it. So you can handle this one without having to get rid of all your fractions, but you still got to work with fractions. So my contention is if you've got fractions in your equation, multiply by the LCD, you're no longer going to have any fractions. Okay.
okay. Thank you.
All right. So here, look at these a second. All right, so all right, 2.4 is problem solving. So it takes up what we talked about the increased and decreased. So we got to follow those things, except now we're going to be setting up equations and solving them. So decreased means subtract. So 5 decreased by a number, the number that we don't know, which is x, is 17. So 5 decreased by x. 5 subtracting x is 17. So there's your equation. All right, real simple one once these are set up. Okay, so now get rid of the 5 by subtracting by 5. So you got 17, take away 5 is 12. Negative x is equal to 12, or x is equal to negative 12. If your x is negative, you can fix it by just making the negative of the other side where the number's at. So that fixes it. Or you can just multiply by -1, divide by -1. They both do the same thing. All right, questions? All right, here's another one. Translate and solve. 3 times the sum. Sum. When you hear that sum, that's a good thing to be thinking about, is things inside of parentheses that are going to be added, which is what sum is. 3 times the sum. And what is that sum? A number and 7. So 3 times a number and 7, 3 times that sum, is the same as, might as well just say is or equals 4 times the number. So 3 times x plus 7 is equal to 4x. And that's that equation right there. Pretty easy to solve. Once we get it, multiply both sides by 3, or both factors by 3. So that's 3x plus 21 is equal to 4. They're working on the opposite side, so subtract 3x, leaves just plain old x, and all there is over there is just a 21. And that's, like I said, if you take that route by going to the right, solving to the right, it really saves you a couple of steps. So it means x is equal to 21. All right, questions about those? All right. So these will be ones I'd like you to solve, and then we'll take the first 2. Hold on a second. All right, we can just look at it on here, actually. And then I can work them over here. All right, so when you get one set up, you let me know. You don't have to necessarily solve it yet, but make sure you got it set up right. 3 times the sum of some number, so some number, and 2 is 15. Three times the sum of some number and 2 is equal to 15. Does that make sense? 3 times the sum, and the sum is some number, which is x, and a 2. And then 3 times x is 3x, 3 times 2 is 6. All right, so subtract 6. So 3x. So the 6's are gone. So 3x is equal to this is weird. That's weird. All right. What happened to my pen? Well, that's not working. I'm just going to write it out. 3x is equal to
9.
Yeah, you're right. I don't know why my thing's not working. Do I have to reload this? It just wouldn't write. I don't know what was going on. All right, let's try again. Three. Here we go. So that's 3. So these are gone, and it's just 3x is equal to 9. You're right.
So is it
X equal
a
3.
-9? Since we're,
Where do you see a negative at? It says is equal to 15.
because we're subtracting 6?
Well, but 15 minus 6 is,
Positive 9.
mm-hmm,
And so X equal 3. X equal 3.
x is equal to 3. And you can put it back in there and see 3 plus 2 is 5. 3 times 5 is 15. So it works. All right. Look at that next one. The difference. So this is going to be something being subtracted. What's being subtracted? Twice a number. And 7. That's the difference of twice a number and 7. Twice a number and 7, and this supplies the negative sign. That's what difference is. Is 5 less than 3 times the number. So 3 times the number, take away 5. Tell me if I got that right.
Got -2.
Okay, so Again, it doesn't matter which side we isolate on. Let's see, let's do negative 3x, which is going to give us a negative x. And then we're going to plus 7 to get rid of that. So negative x is equal to 2. So what's the solution? We got to have a single x, so change the sign of both of them, which is the same thing as multiplying by negative 1. Okay. All right, so working on these here. Give you a couple of minutes. I'll be right back.
I can't hear you, Professor Cruz.
All right, so I was going to ask y'all, did any of y'all have classes out at the face-to-face at the campus? Does anybody have?
Yeah, my lecture class.
Yeah, I have one. This was my only class that was supposed to be face to face, so no.
Well, they changed this one back to, but they just started back today, the face-to-face, and there's like 8 people in the class, strange. All right, so twice the sum. Twice the sum. And what is that sum? There's the things I'm summing up. 4 times a number and 3. The sum of twice the sum of 4 times a number and 3 is what? Is 22. Times 4 is 8. 2 times 3 is 6. So then these are going, so you got 8x is equal to 16, right? Does that look good?
X equal to?
Yep. X is equal to 2. And you can kind of check it back over here. 2 times 4 is 8. 8 plus 3 is 11. 11 times 2 is 22. So that's it. All right, give that one a try. All right, so the sum of twice a number and 7, so there's the sum, is, that's what that's supposed to be going down with 2 equal signs. Twice a number and 7 summed up is another sum, the number just by itself, and 6. X equal to -1.
Yes, I got a -1 as well.
Okay, good. All right. So what happens when you set up number 5? I'd like to hear somebody yelp out how they do that. All right, so Greg Gorell, Mr. Jackson, did you get that straightened out about ProctorU? Because if you, because I think what you got to do, you got to create your ProctorU account at ProctorU, then go back to the My Math Lab, and then when you click on that test, it'll you're going to have to download a plugin or whatever they call it now, an app. And then and then that should get you in, because then you have to log in back into that same account in order to take it. So if that didn't work, I would take advantage of their tech support, because it looks like you're using Windows. So
Yeah.
When do we take the test? I know it's on the 7th, but is it like at any time or?
But we're gonna have it over 3 days. But that test is not going to be proctored. But there is like a little test proctor thing in there, a little assignment for you to do. So that way, when we do this, it'll, you should be ready for it.
Well, when I was trying to do it,
Mm-hmm.
it kept on telling me that my system was out of wasn't updated, so I updated it. And then after I updated it, it was telling me something about the Wi-Fi connection. I'm just like, how, when I have the highest speed? Then like it was like a lie. So I was trying to troubleshoot it, but I guess because
Okay.
it was
Is it Windows?
yeah, but I
Okay.
tried on. I have 2 other computers up in here, and they Chromebooks, and I tried
A
on that.
Chromebook won't work. That I know.
Oh, okay. Well,
It's got to be Windows or Mac. So all I can say is, if you did what it said, like you got to go and have an account at ProctorU, and then you go back to your test in My Math Lab, and you're not using the, you're using that little, what is it called? It's the little assignment. So under assignments, this is the one that's set up right here. See that? Is that what you're using? The ProctorU review
yeah.
check? Okay, well, like I said, if see, it's not going to let me do it, or it shouldn't let me do it. See, that's because it says I don't have a student account, but that right there kind of stands in for the test. Like I said, for the first test, you're not going to have to worry about it. For the midterm, it's really important, so we need to get straightened out before then. We will have like one of the tests, probably like test 2 or test 3, will be a dry run, so that way you're make sure you're ready to go on the midterm. So like I said, if you're doing all that, and like I said, sometimes the things that I have to do, especially with Windows, is reboot a computer. Sometimes that fixes things. So, but like I said, if you doing those 4 steps, like I said, make sure you got an account at ProctorU. Go back to the test, go on to it, and when you do it the first time, it's gonna have you download some kind of app thing, and you got to install that. And then it should go in, and you log in back into that account you created, and then from then on, your camera's going to come on and your mic, and it's going to record you, and you got to show your ID and all that stuff. So then you're recorded throughout. But if it's not working, if you're doing that, contact the ProctorU support, because like I said, I've not had anybody that's had any issues like that you're having that I can think of. Because I thought I saw on there, it said something, click here for live support.
Yeah. I did click it right before I sent the email. I've been trying to troubleshoot it before I even emailed you. I tried to troubleshoot it.
Well, like I said, you're probably going to have to just contact them at that ProctorU thing, because I mean, I've not had a whole lot of people have trouble with it. And I know it might be slightly different this time, but we'll talk a little bit more about it on Thursday. I'm sorry, on Wednesday. All right, let's go back over here. All right, so here we got a difference. The difference of 3 times a number and 1. All right. 3 times the number and 1. Difference is subtract. Is, that's the equal sign, the same as twice the number. See if that works. right, so this one's gonna have to be there's only one number. So it's 3x is equal to 2x plus 1. So this one's not going to be that hard because when we subtract the 2x, it's going to give us a plain old x there. So these are gone, and we got x is equal to 1. And you can see that works because 3 times 1, take away 1 is 2. And 2 times 1 is also 2. Three times a number plus 6 is equal to 2 times the number plus 8. Does that look good?
I'm having
So
trouble
for this one,
understanding.
I put the parentheses
Bring in parentheses.
Around what?
around the x minus 6.
Yeah, I put
You mean around this?
parentheses around x minus 6 and around x plus 8.
Me too.
I don't understand when to put parentheses and when I don't.
Well, okay. See up here, it mentions sum. So this is saying 3 times the number. So that's 3 times the number. Minus 6. Up here, on number 4, well, let me back up. See, these are specifically saying here, twice the sum of a number and 3. So this is just saying 3 times a number. Well, that's 3 times the number minus 6, because the 3 times does not involve the 6. If they did, they would probably say something 3 times the difference of a number and 6. They would use the words difference or sum. See, they specifically got that, what do you call that? Comma. Break those two. 3 times the number minus 6.
I got 14 also.
Me too.
All right, let's see. So you don't really need the parentheses there because they're not multiplying the whole
I
thing.
didn't use a parenthesis either.
Yeah, you don't need it. I mean, you can put it around there if you want to, but there's nothing to multiply by.
Mm-hmm.
All right, so subtract 2x. So that's just going to be x minus 6 is equal to 8, and then plus 6, plus 6, x is equal to 14, right?
I got negative 14.
What are you getting a negative at?
Because I did,
Positive 8 is equal to the number plus 8. Okay. So tell me what you did.
because I got 1x minus 6 equals 8, and then I did minus 8 on the 8 side, and I did minus
Okay.
8 on the 6 side. So the 6 wasn't a
But then you
negative.
got that, but then that way you come out with a negative X here, don't you?
Yes.
But that's not the same as negative 14. That's a negative X is equal to 14, right? Or negative 14. Is this what you have? That's what you have, isn't it?
Yes.
Okay. But that's the same thing as this, because this is not negative 14. It's negative X is equal to negative 14. So therefore, if we multiply both sides by negative 1, to make this a positive X, because you don't not interested in what some funny value of X is. You want to know what one positive X is equal to. So that's why that comes out to be 14. Because true, one of your steps is negative X is equal to negative 14, but you got to go one step further and change the signs of both of them.
Oh, okay. So it doesn't matter which side we take from, right? We can take from either
No,
side.
you can do it from either side and it'll work out the same. But as I had said here, the way to fix this, the easy way, if your X is ever just a plain old negative at 1X, then just swap the signs there. In other words, take the opposite, which is the same thing as multiplying by negative 1 or dividing by negative 1 or whatever.
Oh, okay.
Because negative X is equal to negative 14 is not X equal to negative 14. That's X is equal to 14. Because once you give this to be a positive X, it also changes the 14 to a positive. All right. The sum of 4 times a number and 2. Now, start thinking about parentheses here. The sum, well, you don't really need the, I guess I'm getting a little bit too dramatic. You don't really need parentheses, but it's not going to hurt because there's nothing multiplying the sum. If something's multiplying the sum, then you got to have the parentheses. But this is just 4x and negative 2 is 5 times x negative 8. And you could put here plus negative 2 plus negative 8, but both of them mean the same thing. And this is a good one too that we can work on the opposite side if you want to. And this this is one reason why I sometimes do bring my x's to the right hand side for this very reason, so that we don't end up with a negative x, because it can be confusing. Because if you bring it over here, then the x's are positive. So that's just going to be a plain old x minus 8. So if it helps you, you do that. It's just that is one reason why sometimes I'll go to the right side with my variables, just so that I don't end up with a negative value of x, because that can get confusing to my, to the head. X is equal to negative 10. Yep, that checks out. All right, now the key with some of these things like 8, and I think also 10, they're giving you some valuable information here. They say that a 25-foot wire is cut into 2 pieces so that the longer piece is 1 foot longer than 5 times the length of the shorter piece. So let me kind of show you. Let's just do a little drawing. All right. So this whole thing from here to here is 25 feet. That's 25 feet. It's cut into 2 pieces. Now, they clearly talk here about a longer piece and a shorter piece. Let the shorter piece be X. It doesn't matter if you get the proportions right because you don't know what they are yet. But let's let this be X. So that's the short piece. So a longer piece right here. Now, so when it says the longer piece is 5 foot longer than, that's what +5 means, right? That's 5 feet longer. And it's not just 5 feet longer than X, it's 5 foot longer than 5 times the length of the shorter piece.
That's 1 foot longer than 5 times the length.
Oh, I'm sorry, thanks. So 5 foot plus 1. So yeah, the longer piece is 1 foot longer than 5 times. All right, so now this is real easy to solve now because both of these pieces have to add up to what? The short piece and the long piece have to equal 25. So these go together, and then we can subtract 1. So that's 6x is equal to 24. X is equal to 4. So this is 4. And then this one is 5 times 4, so that's 20 plus 1. So this is 21. And then you can see that this works. 21 plus 4 is 25.
I'm still confused on what you got for number 7 because I got 6 and I'm looking at your work and it says for the -2 equals 8 minus x minus 8, you did +8 and -8 on the other side.
Mm-hmm.
Wouldn't you have to do the same thing on both sides?
Thanks. Oh boy, you're like on top of things.
Because I was just trying to figure out like what I did wrong, and I was just like looking over it, and I thought I did all my math right.
Y'all gotta watch out for me, because I told you I'm like all zonked out from going to that class today. So this is going to be 6. Yeah, that's important. Doing things the same thing to both sides, and you can see I do it. So it's let me just write that whole thing off. right, now it helps to know some formulas for basic geometry. Like, for example, a garden, we've got a garden here, and it just tells us that the width of the garden is 4 meters. 24 meters of fencing is needed to enclose the garden. Well, hopefully you might be familiar with this formula. And we can kind of just look at it like this. If you forget it, you can just kind of go back to this. The perimeter is the walk around that rectangle. And a rectangle just means it's got 2 lengths that are the same and 2 widths that are the same. So that's where this formula comes from. P is equal to 2L plus 2W. Now, they give you some important information here. They give you W, or the width, is 4 meters. And in disguise, they're telling you 24 meters of fencing is needed to enclose the garden. In other words, that's your perimeter there. So we know these 2 things. And then we also know that W is 4. So now we can just say 2L plus 2 times 4 is equal to 24. 2L plus 8 is equal to 24. Subtract 8, subtract 8. 2L is equal to 16. Put it up here. Divide both sides by 2. L is equal to 8. All right. So this one, we kind of utilize the same kind of thing here, the structure. They tell us that both pieces add up to 25. But here we use the formula for the perimeter of a rectangle. And we just fill in the 2 bits of information they got, that W is 4 and that perimeter is 24. So that means the length is 8. So 2 lengths of 8, that's 16. And then 4 is 20, and another 4 gives us 24. Okay? All right, the last one here. Again, this is very similar to this one up here. It helps to draw a picture. And again, we're going to have what information? We got 3 pieces. The larger piece is twice the smaller piece. So again, let's put this as X, the smaller piece. So the larger piece is 2X. It's twice the smaller piece. And then the other piece, which is the 3rd piece in the middle, 5 inches more than the smaller piece. All right, does that make sense? You got the smaller piece is X. The larger piece is twice the smaller piece. And then the 3rd piece is 5 inches more than the smaller piece. So it's X plus 5. So now, and these have to add up to 53. x plus x plus 5 plus 2x. They have to be 53 because that's how much it was before it was cut into pieces. So now let's put it over here. So that's 2x and 2 more x's, so that's 4x. So that means 4x is equal to 48. Divide by 4. X is equal to 12. So this is 12. This is 12 plus 5, 17. And then this is 24. And all three of these should add up. Let's see. Yep, 53. So there we got 12, 17, and 24. Any last questions? Like I said, try to, I mean, one of your assignments is in there, that ProctorU thing. See if you can get it running. If not, we'll talk about it, but it's not that important for this first test. The first test, what I'm going to do is I'll probably open it up on the weekend, like Sunday, and then it'll be open up Monday, and then it'll still be open up Tuesday. So next Monday, we will still review this material so that if you got any questions, you can get them answered. So as long as you take that test before that end date, it should be all right. All right, this is going to be probably the easiest test you got here. All right. So any last questions?
So what's our homework for tonight?
So on here, this is something that should be stapled to your forehead here, okay? See that? (2.3) and 2.4. We always keep up with this. So we will finish up the chapter on Wednesday, okay? Any questions?
Can you go back for a sec? I just want to copy it down. I'm finished.
Any last questions? All right, well, I'll see you Wednesday. If you want to hang around here, I'll be
Thank you, Professor Cruz. Good night.
All right, good night, Mr. Cruz.
Mom was ordering a camera with you.
Okay, I'm about to say hi.
Mom, come here.